Forestry module. The Forestry module is used to analyze forest data. After successfully importing data, first prepare the data. If absolute coordinates are required, first perform coordinate transformation on the data, and then remove the main forest area. And perform noise reduction processing. Forestry data is generally processed using statistical filtering functions for noise reduction, ground point extraction. Select the prepared forest data and click on ground point extraction. Adjust the resolution size based on the sparsity of the original point cloud ground data. If the ground data is sparse, increasing the grid resolution can improve recognition accuracy. Specific attempts can be made repeatedly based on the extraction results. Height normalization. Elevation normalization is the process of unifying the overall elevation of data based on ground points. At this point, select the optimized forest data and extracted ground point data. Click on elevation normalization. Select the data corresponding to the ground point column. As the extracted ground point, click OK to generate a standardized point cloud. Extract stems. Select normalized data and click on tree trunk extraction. The fitting accuracy can be adjusted according to the extraction effect, and other parameters can be adjusted as needed. This step will obtain two sets of calculation results. One set of data is automatically recognized tree trunk data, and the other set of data is slice data. Slice data is the complete original tree trunk. When the automatically recognized tree trunk information is incomplete, in addition to readjusting the calculated parameters, complete tree trunk information can be obtained by manual selection. Next, we will display all the tree trunk and slice data. Select the slice data and enable 3 display effect in the properties. The exposed green dots are unrecognized tree trunk dots. Turn on the cropping function. Both quick and fine cropping are available. We take a relatively concentrated and identified area as an example to crop at. Cut out the slice data that is not recognized as tree trunks. Adjust the data in the extraction area appropriately, and clean up some non-tree trunk data for backup. Extract DBH. Select the recently trimmed tree trunk slice data. Open the breast height diameter point extraction, and set the filtered data according to actual needs. Reopen the previously automatically recognized tree trunk data. Open the DBH point extraction again, and extract the tree trunk data. After selecting all 2 sets of DBH point data extracted, merge them to obtain complete DBH point data. Extract trees. Select the complete DBH point data and the complete normalized point cloud of the forest area and click Monocular Segmentation. Confirm that the data corresponding to the DBH point and normalized point cloud are correct. Based on multiple segmentation results, the values of clustering prediction and minimum clustering can be adjusted. To achieve the best segmentation effect, select the path for saving monocular segmentation data and then click on Calculate. Single scene segmentation is completed and the individually colored forest point cloud data can be seen. Property statistics. Select the point cloud data for single tree segmentation and click on the tree attribute statistics. The output file of importing single tree segmentation can be seen in the single tree attribute bar on the right side. The attribute list includes the X, Y, and Z coordinates of the tree trunk, as well as its height and DBH. Double-click on any data, and the data will be highlighted in white in the single-screen segmentation point cloud. Click the Export function on the toolbar above the Attribute list to obtain the CSV table corresponding to the data table. Save data to the specified directory for browsing at any time.